In this video, we are going to do 18.03 ginventory. All right, so I have the problem opened up in racket. So just G stands for game, right? So anywho, notice how some of the data design steps are already done. We're going to do the function pretty shortly. So let's just quickly run over the data definitions here that are already done. Class is one of either knight or mage, and here is an item. It has a name, a class, which is either knight or mage, level, attack, defense points, and then a price. All right, so that's a lot of things. And here's the interpretation of all the data, right? So let's keep going. Here's a template for the item, and here's a list of items. And finish the template for list of item. All right, so here it is. Pause it and try to do the template for list of item. We'll have spoilers in 3, 2, and 1. All right, I'm gonna assume that you guys took a good swing at it. So now let's go over it together. So let's just quickly scaffold this out. So it's gonna be define list item temp. All right, so we're given a list of items. So let's call this our parameter. Let's name it itm-ls, right? So that's pretty close enough to the original spelling. -ls for the list. All right, so since this is a list of items, list is either empty, so we're going to need 2 cases of cons. So on the empty case, right, if the item list is empty, we want to do something. Otherwise, right, we want to do something to the first of the list, and then the rest of the list, which is going to be a recursive call to the template, laying out a good scaffolding here, like so. And this, again, since this is a non-primitive type, that's not numbers, not strings, not boolean, it's not something that comes with racket, right? It's a data type that we defined ourselves with define struct over here, right? It's a non-primitive data type. Well, we want to wrap this in a helper function to item temp. And this would refer to this template, right? We might use this. Anywho, that is how do you template the list item temp. All right, so now let's move on to problem B. Problem B says, design a total price function that consumes a list of item and produces the total price of all the items in the list, all right? So pause the video and try to work through total price on your own. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So signature, so total dash price consumes a list of item and produces the total price of all the items in the list, right? So that's gonna be a number because numbers are prices, right? They represent prices pretty well. So next is the purpose. So produces the total price of all the items in the given list. All right, signature, purpose. Let's stub this out. Total price consumes a list of items and then produces a number. It's a good stub to run against some examples here. Check, expect. Total price. Let's say the list of items is empty, right? We have no items in our inventory. We'll just produce 0, all right? Let's do another test here. Total price, all right? Let's grab the data examples from up here, right? Because we're gonna need them. So I'm gonna paste it into this block here. And likewise, the list. Here it is. All right, so we don't have to keep scrolling up and down. And I'm gonna separate this from there. All right. So let's do a list of sword and wand, right? What should this produce, right? The total price of a sword and a wand. Well, let's look at the sword, right? So this is the name of the weapon. This is what class it belongs to. Only knights can wield it. This is, I think, the attack point. So let's just double check, right? So attack, defense, and then price. So the level, attack, price. Level, attack, defense, price. All right, so price is way at the bottom over here. All right, so that's good. So you can see it all the way here. So that's going to be 44 plus the wand price, which is 54. All right, so this should produce the addition of 44 and the wand price, which is 98. All right, let's do another example. Total price list, and then let's do staff. Right, so this is the staff, and then we'll do longsword. Longsword, right? So staff is, we see that the staff is 98, and then longsword is 90 coins. All right, and you can also do a 1 length long list, right? It's not too exciting though, but let's just do it anyways. So a 1 element long list, let's do the I think we used all. We'll just do sword, why not? So this is just going to produce the price of the sword. 44. We can do 44 plus 0. Right, that's what it actually does, so it can be more specific that way, but it's fine. Alright, so I'm going to run the test against our stub here. We get a bunch of differs, no typos. Let's comment this out. And let's grab the template for list of item that we did above earlier in problem A and use it as a scaffold. Alright, so now really pause the video. Hopefully this should be all the mental scaffolding needed for total price. I'm going to go with spoilers in 3, 2, and 1. Alright, I'm assuming that you guys took a good swing at it, so now let's go over it together. So in this empty list case, right, if the list is empty, just produce 0. So like so, right? Otherwise, right, in all the other cases, right, let's do the 2-element long list, right? Sword and wand, right? So sword is 44 and wand is 98. So we're going to add them together. All of these examples have an add here. So let's just do that, right? We're going to need an add here. And we're going to need to grab the prices of them. So item-price will get us the prices of all the items. And what do we want to add it with? Well, we want to add it with the total price of all the rest of the items, which we'll assume will fulfill its purpose statement, like so. So let's just run this, and we see that 98 differs from 142. So probably got this test wrong, right? Sword is 44, right? So wand is 54. Right, so the test was wrong. I paid 98, right? That was the staff price, right? So my bad, like so. And we can run this code, and we see that. I think that's just a bug with Racket. Yeah, I hide the panel, and it works. So it's kind of weird. Anyways, that is this problem done for total price. Anywho, now let's move on to the next problem. Problem C. I'm going to scroll down here. Design a function filter-class that consumes a list of item and a class and produces only the items with a given class. All right. So pause the video and try to work through filter class on your own. We were spoilers in 3, 2, and 1. All right. I'm assuming that you guys took a good swing at it. So now let's go over it together. So first we need the signature. So filter-class consumes a list of item and then a class itself and then produces a list of item. All right, because we want to produce only the items with the given class, right? So items is plural, so we have to produce a list of items with a given class, right? So signature, let's do the purpose statement next. So produces only the given items with the given class. All right, so signature, purpose, stub this out to define filter class consumes a list of items and the class itself and produces a list of items. So let's use empty as the dummy value to run against some tests here. So check expect filter class, right? So let's do an empty list and we'll say night, right? So there's no items in this list, so just produce empty. Right, let's do some more examples here. To do some more examples, we're going to need these example data, right? So I'm going to copy and paste it down below here to prevent, scrolling up and down. All right. So we're going to do another test here. Right, this time, right, let's say we're going to use all items, right, which is the list that contains all the items, the sword, the long sword, the staff, and the wand. Right, that'll make it more interesting. All right, so give me all the items that are for knights only. All right, so this should produce. All right, so sword and long sword, right, these two are items that are for knights. All right, let's do one more example for mages. So it's going to be mage is the class. And you're welcome to, expand the classes and really play around this, right? Add more items, add more classes. But nonetheless, for the sake of time, right? So given all these items, right, which ones are suitable for mages? Well, the wand has the class of mage and the staff has the class of mage. So we're going to produce wand and staff. All right, so those are a good set of tests. Let's just run against our examples here. We get failing tests here, but it's fine. No problems with the test itself and the stub here. So now let's grab the template for list of items, right? Because we did the scaffolding, which is going to help us out here. So here's filter class, rename this. This function consumes 2 arguments, the item list and the class. All right, so now really pause the video. Hopefully this should be all the mental scaffolding needed for filter class. I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it, so now let's go over it together. So in this empty case here, we just produce empty, right? Because there's no items in this list, right? So it doesn't really matter what the class is, right? The given class. Otherwise, right, what do you want to do? Well, sometimes, right, some of these items are in the given class, right? So for this case, knight, right? So sword and longsword are for knights, but wands and staffs are not, right? So sometimes we want to include something, sometimes we don't, right? So that indicates we need some decision making. So if, over here, all right, so if what do we want to compare? Well, we want to get the items class here, and we want to compare it with a given class that we're given into this function, right? That we're given in this function. And there are strings, so string equal, class. All right, so if it is part of the given class, well, we want to cons it on, right? So cons the item itself onto the rest of the list, right? Which will assume a call to filter classes onto the rest of the list, right? Because there might be more, you know, if we add, you know, something like a dagger here, right? And we make a dagger example, right? We don't know if, you know, there are other, you know, items in the list that are for knights. So we have to keep going through the rest of the list. All right, so we'll assume that it, you know, works for the rest of the list. And likewise, in the false case where it's not part of the given class, right? Well, we just keep going, right? And don't add it. All right, likewise, this takes 2 parameters, right? Filter class takes 2 arguments, like so. So there we go. All right, and all 7 tests do pass. All right, so now let's move on to the last problem, problem D. So problem D says, design a function raise all prices that consumes a list of item and a number and produces a list of item with all the items prices increased by the given number. So this given number here. All right, so pause the video and try to work through raise all prices on your own. I'm going for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it, so now let's go over it together. So first is the signature, raise all prices, consumes a list of item straight from the purpose statement and a number and produces a list of item with all the prices increased by the given number, right? By that number. Signature purpose produces an item with the price, produces the given list of items with the prices increased by the given number. All right, so signature purpose, let's dub this out. Define raise all prices, right? With the item list and then the number. So we'll call this the raise, right? Because that's what we want to raise the prices of the items by. And it produces a list of item. So we can just use empty as a dummy value to run against some tests and examples. So let's illustrate what this function does. Prices. All right, so let's give it an empty list. And let's say we want to raise it by 1,000, right? It doesn't really matter, right? There are no items in the list. So we can't really raise any item prices if, you know, the list of items is empty. All right, let's do another example here. So check this back. Raise all prices. And we're going to need our examples up here. So I'm going to cut it and paste it down here. All right, so let's raise the prices of, let's say I have a list of wand and staff, right? What should this produce? Well, it should produce a list with the, you know, prices raised, right? So raised by how much? Well, we have to give it the number we want to raise it by. So let's say, you know, 10. Well, let's do 9, right? So like so. All right, so this, right, raise prices of the wand and staff by 9 coins should produce a list with the wand. So I'm going to copy and paste it here. So like so. The wand and the staff. So this is the staff here. All right. And then we're going to increase the price, these are the prices, by 9. All right. So like so. So hopefully you get the idea of what this function does. All right. I can do another test with the sword and longsword and all the items, but for the sake of time, I'm just going to do these 2 tests, right? I encourage you to pause the video and write, you know, a few other tests. Nonetheless, right, this should illustrate what the function does, right? Given the number 9 and this list of items, increase the price field of each individual item and produce the final result in the list. All right, so let's just run these stub against our examples here. Just get a mismatch, it's fine. I'm going to comment it out. All right, let's grab the template for a list of item. Here it is. Gonna paste it down. Something that we scaffolded in problem A. Raise all prices. Consumes the item list itself and also a number. So it's gonna be the raise. All right, so now really pause the video. Hopefully this should be all the mental scaffolding needed for raise prices. I'm gonna go for spoilers in 3, 2, and 1. All right, I'm gonna assume that you guys took a good swing in it. So now let's go over it together. So in this first case here, right, the empty case, well, we just produced the list empty, right? Like so. That's what our examples tell us. All right, now comes where the harder part. So we have to produce a list of items at the end of the day, and cons is the only way to do that. So that's what we're gonna do. We're gonna cons on to cons what, right? Well, we want to update the price of each individual item by the given raise, right? So let's just wish that we had this function. Update price of the given item. So this is going to be item. And then we have to pass in the raise, the price raise itself, right? So what do we want to cons the updated price of the item onto, right? Well, onto raise all prices of the rest of the list, which we'll assume will follow the purpose statement here, right? All right, so now we have to do update prices, right? So update prices, right? This helper function is going to consume an item and then a price, which is going to be a number, and then produce an item. All right, so pause the video and try to work through the solution for update prices. I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. So now let's go over it together. So signature, purpose, so produce an item with the price increased by the given number, or number increase, given increase, given raise, right? Produce the given item, actually. The given item. All right, that's way better. All right, signature, purpose, let's stub this out. So define update price, consumes an item, and then a number, so raise, and then produces an item. So just spit out the item that we're given. All right. Next, let's write some examples here. So check, expect, update price. We only need to do one example. So let's grab the staff here, right? So staff here, and we want to raise, all right, right now it's 98. So let's add 2 to it, right? And that would mean that we want to produce the staff, but with the price being 100. So the price field over here is going to be 98 plus 2, right? You can write 100 in here as well, but you know, I'm going to be more explicit here. All right, so let's run our stub against our examples here. Raise all prices, expects 2 arguments, only found 1. Whoops. This argument takes 2. Right, this function takes 2 arguments, so there we go. All right, so we just get mismatches here, but that's fine. So you're welcome to write some more examples for update price, but for the sake of time, I'm just going to skip that. Going to comment that out. And now let's write update price. All right, so let's grab the template for something that consumes an item, because that'll get us there, right? So like so. Let's scroll down here and update price. All right, so now really pause the video and try to work through update price on your own. I'm going to go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing in it. Now let's go over it together. All right, so this is going to be make item, right? Because we have to produce an item according to the signature here, right? Like so. So hit Control I to reindent there. In fact, I'm going to space this down and then hit Control I because I like it looking more like this. All right. So we're given the increase in price here. I forgot to put the raise here as the second argument. So we're given the raise here, right? And we're going to add it to the price, right? So here it is. Here's the item's price. I'm going to add it to raise. And that should fulfill and pass the test. And likewise, we see that all 10 tests do pass. So we are pretty much done with this problem. So Control I to reindent, test, review, and refactor, and submit it to Handin to check your score. All right, and make sure it passes the grader test. Anywho, that is about it for this video, and I will catch you in the next one.